So today we're going to be looking at linear graphs, and we're going to try to see if we would be able to determine the equation of a straight line using the graph of the line, two coordinates on the line, or using relationship between two different lines, so whether they are parallel or perpendicular. This is going to be found in both CSEC Math syllabi, so additional maths, and the CSEC general maths. So as you can see here for additional maths, this would be the requirements and what we'll be covering today. In the CSEC Math syllabus, this is what we'll be covering as well. So they come from both syllabi. So the first thing we could look at is y equal mx plus c. Y equal mx plus c. So y and x, these are variables. Now the m represents a constant, and this constant specifically refers to the gradient, and the c refers to the y-intercept. So the question is, what do these two things represent specifically? So if we were to have an xy coordinate graph, this is the y-axis and this here is the x-axis. So this would represent points of x from this variable here along this axis, and the y variable would represent things along the y-axis. Now what a gradient does basically tells us how much is this line, at what rate is y increasing by or decreasing by. The y-intercept tells us where it crosses the y-axis. If we had a line here passing through this graph, this here would be our y-intercept. The gradient, we could calculate the gradient in order to figure out what the gradient is. So we could put for this how steep it is. As you can see, this is rising. So this would be our change. Delta means change in y, and this here means delta x, change in x. So it's moving from this point to this point of x, then up to y. So our gradient is the rate of change here, which would be change in y over change in x. In other words, what we call y2 take away y1, which is basically the change in y, over x2 minus x1. So this here represents the gradient. So I want you all to take that down, and then after we'll probably look at a graph. Alright, so let's look at this diagram. Now, remember we said that the equation of a line is written as y is equal to mx plus c, where m is the gradient and c represents the y-intercept. So as you can see here, the line crosses the graph right at this point here. Now this point here represents what number? 3. So this here is 3. So we know that our y-intercept, which is c, is equal to not just any 3 but positive 3, because there is the point where it crosses the y-axis. So we know that the y-intercept is equal to 3. Now the next thing we need to do is calculate the gradient. The gradient is another important part of the linear equation. Whenever you have a linear equation, there are two important parts, the gradient and the y-intercept. Now we said that a gradient is also equal to y2 minus y1 over x2 minus x1. Now we need to figure out what is y2 minus y1, x2 minus x1 could be. Now basically what these are any 2 points along the graph. So when I say any 2 points, if you're looking at this blue line, we need to see where the y-axis intersects with it. So for instance, when I'm looking at this looks like 1 at 1. When x is 1, y is 5. So then this coordinate is 1, 5. When x is 2, y is 7. So if I had a coordinate here, it would be 2, 7. This one here, 3 matches with 9. So I know here is 3, 9. So what I can do now is pick any of these two coordinates, any of these 3 coordinates, or any coordinate for that matter along this line. So I'll pick these 2. So I'll have 3, 9. I'll use this one, and 1, 5. Now the thing is, does it matter what I use? No, it does not matter. Whichever one you use, you'll get the same answer. So the first coordinate I'll have is 1, 5. So I'm gonna call this first value x, because remember 1 represents x. So this first one is gonna be x1, and the next one 5. That's a corresponding point, which is here, which represents y1. Likewise for the 3, 9, the first one, x, is represented by 3, as you can see on the x-axis. So this could be called x2. and then we have 9, and that 9 is going to be right here on the y-axis, so we call that y2. Now at this stage, this is kind of like if we were given 2 coordinates, we would be able to calculate a gradient, which is important, and from that we could also calculate the y-intercept. But for now, let's go from this point of view. So m would be equal to y2. Now which one is y2? Out of these values, which one is y2? Right, so 9 is y2, and I'm gonna subtract y1, which is 5, and that's gonna go over 3 take away 1. So my gradient is equal to 9 take away 5, which is 4 over 2. Now this is the same thing as saying 4 divided by 2, which is 2. So therefore my gradient is 2. So now I could rewrite this equation as y is equal to, what does the gradient represent? It's represented by 2. So 2x. And then now we have the y-intercept. The y-intercept is 3, so we would say plus 3. So the equation of the line that we have here is y is equal to 2x plus 3. That's the equation of this line. Now this is important because if we want to figure out what any coordinate would give us, we could use this exact formula. I want you to take this down so you could see what we did here. This is if we had to identify it from a graph. Now I'll show you how it works, so you could see how this equation links back to what we have here drawn as a line. So take that down. Let's look at this equation and try to get like a basic understanding of what it's actually doing. So we say that we have a gradient of 2. If you notice, the graph is going up. Whenever the graph is going up, that means it's increasing as x increases. So if you can see here, it's increasing as x increases. Now 3 represents the y-intercept, which basically tells us the value when x is equal to 0. So how does this work? So we have y is equal to 2x plus 3. Let's see what it would look like when x is equal to 0. So then that would be y is equal to 2 times 0 plus 3. And what is 2 times 0? That's going to give us 0. So 0 plus 3. So y is equal to 3. So when x is equal to 0, y is equal to 3. So then our coordinate would be 0, 3. As you can see here, we have a coordinate 0, 3. Now, next one. Let's try it when x is equal to 1. So when x is equal to 1, we're using the same formula. 2 times 1, so y is equal to 2 multiplied by 1 plus 3. So then we'll get 2 plus 3, which is 5. So when x is equal to 1, y is equal to 5. So that means the coordinate at that point would be 1, 5. As you can see here, at 1, coordinate is 5. So 1, 5. And here is 0, 3. So if we try that now for x is equal to 2, we could say y is equal to 2 times 2 plus 3, which is going to be 2 times 2, 4, plus 3, that's equal to 7. When x is equal to 2, y is equal to 7. So therefore, the coordinate for that would be 2, 7. Okay, so at this point is 2, 7. So basically, that's how we get these coordinates. So now I'm going to use these 3 values in an arrow diagram, right? Just to show you what's going on here. So we start at 0, then we went to 1, then we went to 2. Now our corresponding values. 0 gave us a value of 3 for y, because let's say this part represents x, this part represents y. So the 0 would give us 3, and the x when it's 1 would give us 5, and then the 2 would give us 7. Now, as you can see here, when we start at 0, we get a value of 3. This value represents our y-intercept. So when x is equal to 0, we get our y-intercept, okay? And next, if you look at this, look at how the numbers are increasing. We're going from 3 to 5. How much do we have to add to get from 3 to 5? 2. So 3 plus 2 is 5, and then to get to 7 we had to do another 2 again. So 5 plus 2 is 7. So we keep increasing by 2. So based on this, what do you predict that the next one would be? Then yes, the next one would be 9. So if you look at this, for instance, 3 goes to 9. So the gradient shows us how much our y value is increasing or decreasing by. That's the purpose of the gradient in this equation. So I want you all to take this down, then we'll look at a different graph. graph here now. So remember, we're still using the same concept. We have the equation of the line y is equal to mx plus c. Alright, so the first thing we could look at from this graph, as you said, is the y-intercept, which is represented by 5. So c is indeed 5. Okay, so it crosses at the y-axis when x is 0, we see 5. So this here is a y-intercept. What do we need to do now in order to obtain gradient?
Take two coordinates.
We take two coordinates that match on the line. So for instance, we have here 2, which goes to 1. So we have 2, 1. Another coordinate, we have 1 going to 3. So this could be 1, 3. Several other coordinates we could use. We could use 3, -1. We could use 0 and 5, -1 and 7 for this one. But we have 2 already. So for the gradient, we say that the gradient is equal to y2 minus y1 over x2 minus x1. And if we were to call 1, 3 the x1, y1, and then we were to call the 2, 1 x2, y2, we would literally have two coordinates and can use this formula. So we'll end up with m is equal to 1 take away 3. I got the 1 from this y2, and the 3 I got it from the y1. And that goes over x2, which is 2 minus x1. So that's going to be 2 minus 1. So 1 take away 3 is -2 over 2 take away 1, which is 1. So now I have -2 over 1. Since a negative divided by a positive is a negative, this would be -2. So my gradient is -2. Now the question is, why is this one negative in comparison to the other one, which was positive? But in this case, what is actually happening is that this is decreasing. As you can see, you see that it's going down. So because it's going down, I would expect that my gradient should also be negative to indicate that it's going down. So even when we look at these two coordinates here, they're right next to each other. X is 1, X is 2. Look at what happens to y values. It went from 3 and dropped down to 1 by 2. So 3 take away 2 is 1. So that's a gradient there that we have. So now that we have the gradient and the y-intercept, we could say that equation is equal to y is equal to minus 2x plus 5 in this case. That's our answer for that one. Same thing that we did last time. If we was to put these into the equations, we would get this answer. Alright, so I want y'all to take that down as well. Try to figure out on your own the linear equation for this line segment LN. So you know what we always go to? Y equal mx plus c. M is a gradient, c is a y-intercept. And here the y-intercept is 4. So 4 right here is the y-intercept. So we know that c is equal to 4. Now the gradient, y2 minus y1 over x2 minus x1 is equal to, so we could have two coordinates. Looking at this, we have 2, 8. That's 2, 8. That could be x1, y1. Then I can have, let's use the L just to keep things spicy, -6, -8. So that's a second coordinate. So -6, -8. This is going to be x2, y2. So we could say our gradient is going to be y2, which is -8, minus y1, which is 8, over x2, which is -6, minus x1, which is 2. So we'll be left with -8 take away -8. That's -16, and then that's gonna go over -6 take away 2, which is -8. A negative divided by a negative is a positive, first things first. Then 16 divided by 8 is just 2. So our gradient is +2, and you can tell that it was supposed to be positive as it's increasing. It's increasing. So our equation of this line would be y is equal to 2x plus 4. Y is equal to 2x plus 4. Y'all got that answer? Alright, let's try one more and then we go to the next phase. So let's see what y'all get for this one. So by now you notice that the process is the same, right? So we have y is equal to mx plus c. First thing first, c is equal to 3. So in this case, we say c is equal to 3. Now we have the y-intercept. We need to figure out the gradient. So the gradient is y2 minus y1 over x2 minus x1. 1. So we pick 2 points. I see here we have 1, 1. We use that. And next one is 2 goes to -1. And we also have 3 going to -3. So we can name this first one x1, call this y1, and this here x2, y2. It doesn't matter if we had named these top ones x2 and y2 and then this one x1 and y1, you would still get the same answer. So in the gradient we have y2, so that's going to be -3 minus 1 over x2, which is 3 minus 1. How convenient that both of these are 1. So then we'll end up with -4 over 2. So in that case, our gradient is -2. Okay, so as you can see here, gradient is -2. So we know that our equation is going to be y is equal to -2x plus 3. We've been saying that the equation of a line can be in the form y equal mx plus c. We can also have it in the form that looks like this. Ax plus by is equal to c or even minus c, and that's equal to 0. So we could have it in this form or this form. Now the important thing about this first form here is useful to us because we know what m is, which is a gradient, and we know what c is, which is a y-intercept. So this form allows us to determine the gradient and y-intercept of a linear equation. Now this form, in order to identify the y-intercept and our gradient, y must be made the subject of the formula. So let's put this into perspective. So we could have an equation that says y is equal to 4x minus 3. We could also have y is equal to 10 minus 7x. In this case, you would notice that this value here represents a gradient. So in this case, our first equation, the gradient is m, which is 4. So the gradient is 4. And what is the y-intercept? -3. That's correct. So the y-intercept is equal to -3. Now in this next question, as you can see, there was a little shift, but the gradient is still equal to the value that is the coefficient of the x, but y must be the subject of the formula. Can't stress this part enough here. Y must be the subject of the formula. So the coefficient is -7, therefore the gradient is equal to -7. However, the y-intercept is equal to what? Excellent. Y-intercept is equal to +10. Alright, so make sure you take this down and I'll go to the next part. Alright, so this situation here is when we have y as a subject of the formula. Now we're going to look at one in this form. Ax plus by minus c is equal to 0. So say for instance we had an equation 3x plus 4y and it's subtracting say 12, and that's equal to 0. Now, we know that this is a linear equation because the order of x is just 1, meaning that it only has up to 1 power in this case. Now, remember, this is in the form ax plus by minus c equal to 0. Now, in this form, we cannot identify anything as yet. What we have to do is put it in the form y is equal to mx plus c. Once we get it in the form y equal mx plus c, where y is the subject of the formula, we have action. We got something to work with. So what we're going to do is try to make this y here the subject of the formula. So we have 3x plus 4, so 4y minus 12 is equal to 0. So what's going to happen here is that we need to make y the subject. So the first thing we could try to get rid of is this minus 12. So we're going to add it to both sides because that's the opposite of minus and 12. So once we add it to both sides, we'll end up with 3x plus 4y is equal to 0 plus 12, which is basically just 12. So then we'll have 3x plus 4y is equal to 12. Now as you can see, y is still not the subject of the formula. Subtract 3x because right now we have it as positive. So if we do minus 3x on both sides and minus 3x here, we'll end up with 4y is equal to 12 take away 3x. And then now to make y the subject of the formula, so I'll put it up here so we don't skip any step, which is equal to 12 minus 3x. So what's being happening now to this side is that 4 is being multiplied to the y. So we do the opposite of multiplying, which is division. So 4y divided by 4, we left with just y. And then we have 12 minus 3 over 4. So now y is the subject of the formula. Now literally this that we have here, we could split this literally into two separate things. So then we could have 12 over 4, which is this part here, and then we could have minus 3x over 4, which is this part here. And notice how I brought back this minus here. So if you look at this, we're looking at y is equal to mx plus c. And what's next to the x? We have next to the x, we have minus 3 over 4. So m is equal to minus 3 over 4, as you can see right here, just to highlight that part. Now our next thing, the y-intercept. Now the y-intercept is equal to this right here. Now that's our y-intercept. With our y-intercept, c is equal to 12 over 4. Since this could go into each other equally, or 12 divided by 4 is 3. So I just identified the gradient of this equation as well as the y-intercept. I was only able to do that because I put it in the form y is equal to mx plus c. So as you can see here, this here represents this. Does that make sense?
Yeah, teach.
Alright, so let me give y'all one to try on your own. You could take this down. So the key thing is to make y the subject, and we move around the numbers next to it. There are certain times you wouldn't have to do all of this because the question could start you off right here at this stage here. Sometimes it could also start you off at this stage here. So you would just have to divide by 4. Whatever the case is, this is a process that we have to take in order to find the y-intercept and gradient. So let me give y'all 2 to try to determine the gradient and y-intercept of this. Alright, so for this first one, we're making y the subject. So the first thing we could do is we have 2x on both sides, so we could subtract 2x on both sides. So once we do that, we'll get rid of this 2x here. So we'll be left with 4y is equal to 7 minus 2x. Now in this case, because we have 4y is equal to 7 minus 2x, we could divide both sides by 4, and that way we'll get the equation y is equal to 7 minus 2x over 4. So in this case now, we could separate it again, and y is equal to 7 over 4 minus 2x over 4. So therefore, m, the gradient, would be equal to negative 2 over 4, or you could even say minus 1 over 2. Y is our equivalent fraction. Negative 2 over 4 is the same as negative 1 over 2. And then after we have c, so c is equal to 7 over 4. Y'all got that?
Yeah.
Nice. So everybody understood that. Alright, so the next one. So in this case, we have minus 5x minus 3y minus 8. So the first thing I'll do, I'll try to get rid of this x here. So instead of minusing, we add it to both sides. So then we will be left with, this is going to cancel out. So we're left with minus 3y minus 8 is equal to 0 plus 5x, which is just 5x. Anything plus 0 is itself. So we want to get a y by itself. So we got minus 8. So therefore we have to add 8 to both sides. So we're left with minus 3y is equal to 5x plus 8. Now in this state, we still can't say that we know what a gradient is or the y-intercept. We have to make y the subject. So in this case, we have to divide both sides by negative 3. Not just 3, but negative 3. Okay? Negative 3. When we leave this alone, we have y is equal to 5x over negative 3 plus 8 over negative 3. Therefore, our gradient is the values we have next to the x. This whole thing is like a number. So we could say m, or the gradient, is equal to 5 over negative 3. And then we can say c is equal to 8 over negative 3. So our y-intercept is 8 over negative 3, and our gradient is 5 over negative 3. Does that make sense? Nice.
Yeah.
So what we have here, two lines, right? What can you say about these lines in relation to each other?
Parallel.
They're parallel.
Excellent. Parallel. Now, what is the y-intercept of the red one? 5. Excellent. So the y-intercept of the first one is 5. What's the gradient of the first one?
2.
Nice. So the gradient of the red one is 2. What is the y-intercept of the green one? Minus 3. So negative 3 is the y-intercept. And what is the gradient of the green one?
2.
2. Excellent. So the gradient is 2. Now, when you compare the gradients and the y-intercept, what do you realize between these two?
The gradients are equal.
The gradients are the same, but the y-intercepts are different, right? So what we can say is that when two lines are parallel and two linear equations are parallel, gradients are the same. Gradients are the same. So as you can see here, y equal 2x plus 5, and then we have y is equal to 2x minus 3. So as you can see here, gradients are the same. Another key thing to note about these is that they never intersect because they're parallel, never intersect. Alright, so look at this one here. What do we have here?
A right angle.
A right angle. So we could say what is the relationship here between these two lines?
Well, perpendicular.
Perpendicular, excellent. So perpendicular linear equations, as you can see here, they have different gradients. So this orange one, what is the gradient of this orange line?
Yeah, 3.
3. Excellent. 3. And what is its y-intercept?
Minus 1.
Minus 1. Now the blue line, what is its gradient?
Negative 1 over 3.
Negative 1 over 3. And what's its y-intercept?
Minus 2.
Minus 2. So we have minus 2 here. You could see it from the graph, which is right here. Alright, so when we have linear equations that are perpendicular to each other, their product would be equal to negative 1. Okay, so the product, in this case, y equal to 3x minus 1. This is our little example. Gradient here is equal to 3. Then we have y is equal to negative 1 over 3x minus 2. The gradient here is negative 1 over 3. So if we were to multiply these two gradients, we would have 3. If we put 3 as a fraction, that's 3 over 1 multiplied by negative 1 over 3. Okay, so then we have 3 times negative 1, which is negative 3 over 1 times 3, which is 3. Negative 3 divided by 3 is negative 1. A negative divided by a positive is a negative. So this here, even so, though it says negative 1/3, this is the same thing as saying negative 1 over 3, or we could have also have it as 1 over negative 3. It doesn't matter. All three of these mean the same thing. A negative divided by a positive will give us a negative. A positive divided by a negative will give us a negative. And if we just put the minus outside, so minus 1/3 as a full number, still negative. So alternatively, the gradients can be seen as reciprocals of each other with different sign. Determine perpendicular gradient of y is equal to 2x plus 3. In this case, the gradient is 2. So we could say m is a gradient, which is 2. Now, if we want to find a reciprocal, we need to put this into fraction form. So in fraction form, this would be 2 over 1. Okay, first thing we need to do is find the reciprocal. So all we have to do is flip that from 2 over 1 to 1 over 2. So the reciprocal of this would be 1 over 2. The next part is multiply the reciprocal by negative 1. So then we will have half times negative 1 as a fraction is negative 1 over 1 over 2 times 1, which is 2. So if an equation has a gradient of 2, its reciprocal would be 1 over 2, and if we change the sign, it will be negative 1 over 2. So as you can see here in this case, our gradient is 2 for this red line, and the line perpendicular to it is negative 1 over 2. So let y'all take that down, and then I'll give you some examples to try and determine perpendicular gradient of an equation as well as the parallel gradient of the equation. Okay, so say for instance with this one, I had y is equal to 2x over 3 plus 5. Now this gradient is equal to 2 over 3. That's the gradient next to the x, the coefficient next to the x, which is 2 over 3. So a parallel gradient would be equal to the same thing. Remember, when gradients are parallel, they equal to the same thing. So then it's going to be 2 over 3. And then when we're looking for the perpendicular gradient, what we have to do is same concept. We flip the 2 over 3, is 3 over 2, and we're multiplying that to negative 1, which is going to give us negative 3 over 2. So our perpendicular gradient will be -3/2, while our parallel gradient is the same as this line. Now we could only do this when y is equal to mx plus c, and so when that is in that form. Otherwise, we would have to put it in that form in order to answer the question. So we're combining everything that we did so far into one question. So I want y'all to do it for these. Alright, so for this one here, the gradient we could see by identifying mx plus c. This is m, so the gradient is m. So a parallel gradient would be the same. Parallel gradient would be the same. Now the perpendicular gradient, we would find a reciprocal of 4. Now remember, 4 as a fraction is 4/1. Find a reciprocal of that, which is 1/4, and then multiply that by -1. So we'll end up with -1/4 as our perpendicular gradient. Alright, so in this case now we have the gradient here being -5/6. So that means that our parallel gradient will be the same. It will be the same, which is equal to -5/6. Our perpendicular gradient now, what we'll end up with is, we flip this, so we flip the 6/-5 and then multiply that to -1/1, which is -6. 6 times -1 is -6/5. Now we have a negative and a negative, so we know that is a positive. So 6/5 is our answer. -6/5 is also the same thing, but it's just nicer to have 6/5. Now with this one here now, we need to make y the subject. So the first thing I'll do is subtract 4x from both sides. So I'll be left with -3y is equal to 9 minus 4x. Now I can divide both sides by -3, and that's going to leave me with this. Y is equal to 9 over -3. Then we have -4x over -3. So our gradient here is essentially -4 over -3, which is also the same as having it as 4/3. So therefore the parallel gradient would be 4/3. It could also be -4 over -3 because it's the same thing. Okay, but it's just nicer to have it looking like 4/3. Now the perpendicular gradient, we find a reciprocal. So we'll have 3/4 times -1/1, which is -3/4. So that is our perpendicular gradient for this equation here. Alright, does that make sense?
Yes.
Nice. Alright, so let me see where this passes through. Let's try it like this. Okay. So what we need to do is determine the equation of a line that passes through the point 1, 5, which is perpendicular to y equal -½ x minus 5. Now, if we're trying to find that line, we must end up with a line that is in this form, y is equal to mx plus c. Now, looking at this, I do not have the y-intercept for this line that we are looking for. So I cannot look at that right now. I do not have a gradient either. However, I can figure out the gradient. How do I know? Because they told me it's perpendicular to this line, which has a gradient of -½ I can figure this out if I wanted to. Now, in this case, since this has a gradient of -½ and we are saying that we are looking for the perpendicular for this new line, we know that it's a reciprocal of this, and we change the sign. So if we flip that, we're gonna have 2/-1, then we multiply that to -1, we'll end up with -2/-1, which is essentially 2. So we know that the gradient for this new line here that we're looking for is 2. Now the question is, do we have enough information to figure out what the y-intercept is? Now if you look at this, we have the gradient now, and they also gave us a coordinate that passes through this line that we are looking for. So because of that, I could use these values to help me find what c is. So basically, how would I do that? This 1 represents x.
The X, yeah.
And what does the 5 represent?
Y.
The y. So out of a sudden now, I have values for everything except the c. So y is equal to mx plus c. So in this case, we have m is 2. So I could say y is equal to 2.
Wait, so 2 times 1?
Yep. You got it. 2 times 1 to figure out what it is. Because basically, our x is equal to 1. That's one value that passes through this line, and y is equal to 5. Okay, so x is equal to 1, y is equal to 5. If we substitute, we could replace this y with 5, which is this, equal to 2 times the 1, and the 1 is from the x multiplied by 1 plus c. So then we'll have 5 is equal to 2 times 1, which is 2, plus c. So how do we get c by itself? We subtract both sides by the 2. That's correct. So then we'll end up with 5 minus 2 is equal to c. So therefore, what is c equal to? 3. So now I know what c is, and I also know what m is. Two important things that I need in order to determine the equation of the line. So therefore, I could say that the equation of the line is y equal mx plus c. So basically, y is equal to, what is m?
2x plus 3.
2x. That's correct. 2x plus 3. Now, why did I leave it close to this diagram? Because I wanted to use this as an example for y'all to see how this works. So it says we have a line which is y equal negative half x minus 5, which is this blue line that we see here. So this here represents this blue line here, which is what we had here in our question. And it's saying that it passes through the point 1, 5, a line that is perpendicular to this same blue line, which passes through the point 1, 5. And with this one here, 1 would be somewhere around here, and 5 would be somewhere around here. So if you see this here now, this basically is the equation of the line, and it passes through 1, 5. So you can see here 2x plus 3, which passes to the point 1, 5. Now notice, this point has nothing to do with this blue line here. But what we are saying is it passes through the point 1, 5. And we use that 1, 5 to help us calculate our y-intercept, which is right here, which is 3. Does that make sense? Alright, so let y'all write this down. Alright, so let's check it out when it's parallel. Okay, so we have two parallel lines here, and I'll do a question from this so you could visualize it when you complete it. So determine equation of a line parallel to y equal 2x minus 3, which passes through the point negative 3, negative 1. Alright, so let's go through this one here now. So the gradient of this here is 2. So therefore, a parallel gradient will be the same. Now it told us that it passes through the point negative 3, negative 1. So this negative 3 represents x, and this negative 1 represents y. So in equation y equal mx plus c, we can do some substitution. So we can replace the y with negative 1, which is equal to, we can replace the gradient with 2, which is multiplied to our negative 3 plus c. So negative 1, and then we could say 2 times negative 3 is negative 6 plus c. So then now if we want to get the c by itself, we add both sides by 6, because this is going to cancel out, plus 6. So we end up with negative 1 plus 6, which is equal to c. So therefore, c is equal to positive 5. Okay, so we have the gradient and we have the y-intercept. So equation is y is equal to
2x plus 5.
2x plus 5. Usually these questions are given in abstract, but this gives you opportunity to see what it looks like in actual graphical representation. Okay, so does that make sense? So you see, way in the beginning we would pick 2 points, then calculate the gradient and determine what the y-intercept is by looking at it. But what we're going to do is we're going to use that same concept to help us determine the gradient. But then what we're going to do is use the concept that we are using here to determine the y-intercept in order to determine the equation. Alright, so it passes through these 2 points here. So you have to determine what is the equation of that particular line.
But teach, which one of them are you going to use to find c?
Well, the question is, do you have the gradient?
Pretty much, yeah.
And once you got the gradient, you can use any one of those to find the value of c. Any one. Because remember, both of them pass through the line. Both of them. So anyone could work. Alright, so we should have it by now. First thing we need to do is calculate a gradient. So this here I could say is x1. This here is y1. This here is x2. This here is y2. So the gradient is equal to y2 minus y1 over x2 minus x1. So in this case, we could say 7 minus negative 2 over 4 minus 1 would be equal to 7 take away negative 2 would give us 9 over 4 take away 1, which is 3. So m is equal to 3. Now what we need to do is figure out what the y-intercept is. Now because it passes through these 2 points, we could use anyone and we'll get the same answer. So I'll do it quickly just for you to see, right? So the gradient is 3x plus c. We know that y, for instance, for this point here. So let's use this one first. So 1 represents x and this represents y. So we could say that negative 2, substituting that y, is equal to 3 times 1 plus c. So 3 times 1, that's going to give us 3. Negative 2 plus c. Now we subtract 3 from both sides. We'll end up with negative 2 minus 3 equal c. So then c would be equal to negative 5. Even if I was to use the next one, I would get the same situation. Y equal 3x plus c. Let's use these coordinates. Then we will have 4, 7. So this one represents x. This one represents y. So we'll say y, replace that y with 7. 7 is equal to 3 times 4 plus c, because the 4 is equal to the x. So therefore 7 is equal to 12 plus c. Now I want to get a c by itself, subtract both sides by 12, and I'll be left with 7 minus 12 equals c. 7 take away 12 minus 5. So in both cases I get minus 5. So therefore my equation is equal to y equal mx plus c. M is a gradient. In this case we said that the gradient is 3x and c is minus 5. So that is our answer. Does that make sense?
Yes.
Nice. Good. We'll do the last part to this same question. Since we already calculated, I'll just attach it to this particular question to save time. We worked out the equation. What we want to do now is determine the equation.
What, say if it's like perpendicular, parallel?
Yep, if it's perpendicular to this particular point that we already have. Determine the equation of the perpendicular line passing through B from previous question. So essentially we have 2 points. These 2 points, what we're saying is there's a perpendicular line to these 2 points, the segment of these 2 points that passes through 4, 7. So what would that equation be? Pun intended. So the gradient from over here is 3, or basically 3 over 1. So the perpendicular gradient would be equal to the reciprocal of that, which is 1 over 3, and we multiply that to negative 1, which is basically negative 1 over 3. So we know that the gradient for this perpendicular line, the gradient must be negative 1 over 3. That's our first part. We also know that we have it passing through the point B, which is 4, 7. So B is 4, 7. It passes through this particular point. So this value is x. This value here is y. The equation of the line is y equal mx plus c. The good thing is we already have the gradient, so we could say y is equal to negative 1/3 x plus c. Now we know that we could use this point because it passes through this point. So y is equal to 7. So then we have 1/3 multiplied by 4. Now I could put 4 as a fraction, which is 4 over 1 plus c. So then I'll have 7 is equal to negative 1 times 4 is negative 4 over 3 plus c. So I'm treating this whole thing as a negative number because negative divided by a positive is a negative. So to get it on the next side, I just say plus 4 over 3. So then I'll have 7 plus 4 over 3 is equal to c. Okay, now at this point you could put this into your calculator, but if I was to write 7 over 1 as a plus 4 over 3, which is equal to c, we just do basic fractions. We have the LCM. LCM of 1 and 3 is 3. 1 to 3 goes 3 times. Then we have 21 over 3. Now remember, 21 divided by 3 is 7. That represents that. 21 over 3 plus 3 into 3 goes once, 4. So then 21 plus 4 is 25 over 3. So I have my y-intercept as well as my gradient. So I can write my equation as y is equal to negative 1/3, which is my gradient, x, and then my c value is plus 25 over 3. So this is the equation of the line when it's in this form here. And just to link it back to the other forms that we had, if you look at this here, we have all of them with a denominator of 3. So if we was to multiply this entire equation by 3, so we multiply the y by 3, the 1/3 x by 3, and this by 3, we'll end up with 3y is equal to negative x, because the 3 and the third's gonna cancel out, plus 25. So if you see here, I put it similar into the form that we had earlier. I could bring this over and we will have x plus 3y equal 25. We could also say x plus 3y minus 25 equal to 0. So this is the equation as y being the subject, and these are other forms of the equation based on what we have learned today. Alright, so hopefully this makes sense to y'all. We'll continue next class. Hopefully this makes sense.